Despite having a good range of tools, I don't have the right spanner to undo the front axle socket head nut on Suzuki GSXR motorbikes. In this video, I'm going to show you how I made this hex key for undoing the front wheel nut on GSXR Suzuki motorcycles. Hello and welcome once again to another episode on the White Dog Garage YouTube channel. My name is Bob. Welcome one and all. Older Suzuki motorcycles have hex nuts on their axles, and you can undo them either with the correct spanner or with a shifting spanner or crescent wrench like this one. Up till now I've been using this tube spanner, which is almost the right size, to undo the front wheel nuts on GSXR Suzukis. I can't help feeling that one of these days I'm going to come across one that's just a bit too tight and I won't be able to get it undone. And that's why I made this one. The socket head on the GSXR is 24mm across the flats, and this will be the dimension of the hex key that I will make in this video. It's a relatively simple machining operation this time round. Piece of silver steel, piece of pipe. I'm going to machine a hex in this end, and I'm going to turn down this end to fit inside the pipe. And then I will cross drill and fit a T-bar. I start work on the length of pipe first, chamfering the T-bar end and then beveling the end that will be welded to the hex plug. Next I used a boring bar to clean up the inside of the pipe and provide a concentric mating surface for insertion of the hex plug. Once I bored out the inside of the pipe, I measured the inside diameter using a telescopic bore gauge and a micrometer. I take two measurements to be sure. Then it was on to the hex plug. First job is to turn down the end that will go in the pipe, even though this is not strictly necessary as it will be inside the pipe and not seen. I then turned the end of the plug down to provide a slight interference fit to the internal diameter of the pipe, which is 29 millimeters. First I touch off on the end and then set my reference zero on the cross slide before taking a series of cuts to bring the diameter down to 29 millimeters.
Full safe mesh.
Safe is fine. See, modern fly screens are perfectly able to...
Having machined the plug end to size, I reverse the plug in the chuck and face off the hex end. I'm going to use the mill to produce the flats for the hex end. To do this, I've set the plug up in a dividing head, which will allow me to easily index around the 6 positions I need to machine the hexagon. The starting diameter of this end is 32 millimeters, which means I have to remove 4 millimeters on both sides to bring the across the flat distance down to 24 millimeters. I'm using a 20 millimeter diameter end mill to machine the hex, and for the first flat I machined down to a depth of 2 millimeters. Then, happy with the result, machine down the additional 2 millimeters to give a total of 4 millimeters in the cut. I could cut 4 millimeters in one pass, but on the first cut I like to make sure everything is going according to plan, as a mistake here could see me machining a whole new plug. With the cut made to the full 4 millimeter depth and satisfied that all is going according to plan, I turn the indexing head 180 degrees, pin it and machine the second flat, this time taking the full 4 millimeter cut in each pass. I then confirm that the distance is 24 millimeters across the flats, and this is repeated again and again until all 6 flats of the hexagon end are machined. I machined the plug in a particular sequence. first machining the end that will go in the pipe, and then fixing that end in the indexing head to machine the hexagon. Doing it this way ensures that the plug is concentric to the pipe, and in turn that the hexagon is concentric to both the pipe end and the pipe itself. If I had machined the hexagon first, I run the risk that any variation in the hexagon will then offset the turned down end that goes in the pipe and misalign the tool. I see this as an example of good machining practice, even though in this case any differences are likely to be slight, and the most likely effect is that the tool will not feel right when I use it.
Stadium. Now, big delays in the valley. There's been an accident between a car, motorbike and a pedestrian. We'll get an update right after this for KQ. Because you never know when foot cramp will strike, there's Cramp Sport. With homeopathic copper traditionally used for muscle cramps and added magnesium to boost your magnesium levels, it's cramp relief, no problem. Cramp Sport.
With the hexagon fully machined, I again check across the flats to ensure the measurement is indeed 24 millimeters.
For master license numbers and terms and conditions, visit aztsecurity.com.au.
It's been 14 years in the making.
I then inserted the plug in the pipe end and hammered it home. I've aimed for a slight interference fit, and this proves it.
Crampy's night crabs in leading supermarkets and pharmacies. Use a corrective. With amazing deals and exciting ideas for those once in a lifetime.
Before welding the plug in, I cross-drill a 14mm diameter hole at the other end, and this hole will be taking the T-bar. Then I weld the plug into the pipe end, first doing 3 tack welds spaced evenly around the outside before welding out the entire joint. I finish the weld by leveling it back so it won't snag my hand in use, and off camera I will clean up the tool surface and give it a coat of paint, and then add it with joy to my toolbox. So, I hope you enjoyed that video, and if you did, I'd welcome a thumbs up, and please share it amongst your friends, and even people who aren't your friends. It's all good. This channel is about making, it's about fixing, it's about restoring, and it's about maintaining stuff. And if you like that sort of stuff, then please, if you haven't already subscribed, think about subscribing. It's easy. Hit the bar down below. While you're there, don't forget to ding the bell so that you're reminded by YouTube every time a new video on the White Dog Garage YouTube channel comes out. Thank you.